So graphing linear inequalities is also going to be very similar to graphing linear equations. Same steps. With these, I am going to focus on getting to that slope-intercept form. That will be easiest with these. So with that, that means we need to solve for y for each of these. So these graphs that we're using here are actually exactly the same graphs that we looked at in the video for graphing linear equations. So these may seem familiar, we're just putting a little twist on them with making it an inequality. So for this first equation, I'm going to solve for y, so I'm going to subtract 2x from both sides. So I'm looking at y is more than or equal to negative 2x plus 4. Now in terms of graphing the line itself, we're going to use the same methods we did for linear equations, meaning I'm going to use the intercept, so we have the coordinate 0, 4, we have the slope of negative 2, which I'm going to think of as negative 2 over 1, so that I get this kind of map of move down 2 and to the right 1. So with that, I can start plotting points. So I'm going to label my axes, put the scale, so I have 0, 4, and then I'm going to go down 2, right 1, and then I'm just going to put a bunch of points. One thing I'm going to think about at this point is how I'm going to connect them, in that we're going to have two types of lines for these graphs. We're going to have the solid line that we've been graphing this whole time, and that's going to show up when we have the more than or equal to symbol or less than or equal to symbol. Another type of line that we're going to have is also a line, but it will be dashed. It will be this dashed line saying we're not quite equal at that point, but there's kind of this barrier there, and that's going to come through when we have strictly more than or strictly less than. So before I connect my dots, what I need to figure out is, do we have the equals part? Which, if I look at my symbol, we do, since it's more than or equal to. So with that, I am going to have a solid line. So I can just connect those dots. So this right here takes care of the solutions for y equals negative 2x plus 4, but I want y values more than or equal to negative 2x plus 4. So what we're going to end up with is a shaded region of the graph where answers will work. So yeah, a few different ways to think about this. What I do is I kind of focus on the y-intercept. It's just kind of a clear point, and you could even think of, let's see if my computer can handle this, zooming in super close. So we have our coordinate here. And I want y values that are larger than or equal to that value. Well, if I think in terms of these y values just on the y-axis, simplifying it to that much, just the y-axis, the larger y values are occurring up here. That's where we have these larger outputs. Like if I think in terms of coordinates, these would be small y values, and these would be large y values. So because I want larger y values, I want to be on this upper side of the equation. So zooming out again, that helps me kind of see which side of the line I want to be on. And the solutions for this inequality are all occurring on this side of the equation. Absolutely everything in this region that is more than or equal to that line that we just drew works for our inequality. And we can even check that it works. Something you can do is just choose a random point in that region. So let's do that. I'm going to choose a point. How about here? So let's see, this is the coordinate 1, 2, 3, 4, 5, 4. All right. So what should happen is this coordinate should work for our inequality. So let's do some side work here and check. We're going to check this coordinate 5, 4 that I just chose. So what this will look like is we'll plug it in. So I'm going to have 2 times 5 plus 4. And what should happen is that should be more than or equal to 4. So we get a 10 plus 4. So we're saying 14 is more than or equal to 4. That is a true statement. 14 is larger than 4, so that works out. So that's where with this inequality, we end up with so many more solutions because we're just looking for things that are either equal to that number or larger, and that makes this whole region of possible solutions. So when we graph linear inequalities like this with 2 variables, you're going to end up starting by just thinking of it as linear, get the line drawn, and then from there you need to think about the region. And I'll go through it again where I like to think about this zoomed in location so I can just kind of simplify in terms of which side is larger and smaller. Okay, let's look at this next case. So I'm going to turn this into slope-intercept form. So I'm going to subtract 5x from both sides. This will be negative 6y less than negative 5x minus 90. And then I'm going to divide both sides by negative 6. And when we do that, that should send up a little red flag that we're dividing by negative 6 and we have an inequality. So we're going to be flipping that symbol. So we have y on the left-hand side. Where we had the less than symbol, that's now going to be the more than symbol. So we just want to pay attention to the sign flipped because we divided by a negative number. For x, we have negative 5 divided by negative 6, so that's going to be a positive 5/6x. Negative 90 divided by negative 6 will be a positive 15. So with this graphing the line, I have my intercept of 0, 15. I have my slope of 5, 6. So the direction I'm moving in is up 5, right 6. So that's the map I can follow. Alright, I need to think of a scale to use here. How about, let's go by 2s. So for 15, I'm going 2, 4, 6, 8, 10, 12, 14, and then halfway in between. And then I'm going up 5 and to the right 6. So it's a little different with the scale, but I could think about these kind of half steps in between there, ones. It's like here's 1, 3, 5, and then to the right 6, 2, 4, 6. So I will actually have another point there. And I'm just going to do that a little bit in the opposite direction. So down 5, left 6, down 5, left 6, down 5, left 6. If we remember graphing this linear equation before, that's where our x-intercept was. Alright, before I connect the dots, I need to pay attention to what symbol we ended up with here. So we don't have the equality part of this. So it's not going to be a solid line. Instead, I want to graph this as a dashed line. So we're just going to, as best we can, and this would be better with a ruler, but we have this dashed line showing that those values that are landing on the line aren't actually solutions. Okay, now I need to figure out which side I want to shade in. And we want the values for y is larger than that line. So we want y is greater than, and maybe you can see by instinct, it just takes some practice sometimes to get used to which side is larger, smaller. But I'm going to go my zoomed in route of, I have this cutoff here, and I want to think about, for the larger values, would I go that direction or that direction? And we want the values on this side. Since we want y to be greater than, we want the y values that are bigger than that line. So we go up. So that kind of gives me an idea of which side to shade in. So we're shading in over here. You don't need to draw that little red arrow that I'm drawing there. I'm just marking it so you can see what I'm talking about, but it's not part of the graph. In fact, I know this might get rid of my, I knew I would get rid of my highlight, but really, this is technically the complete correct graph right here, just with the shaded region. All right. Let's look at another case here. So this is all solved for us. We don't have any solving to do. So we have a y-intercept of 0, -2. We have a slope of -3. And I'm going to think of that as -3 over 1. So for slope, I'm going down 3, right 1. All right. So with that, I'm going to make my axes and scale. So we're down at -3. Nope, we're down at -2. And then a slope of -3. So down 3, right 1, down 3, right 1. I'm going to go in the opposite direction. Left 1, up 3, left 1, up 3. Left 1, up 3, left 1, up 3. Alright, before I connect those dots, I'm going to see which symbol I'm working with here. And since it's strictly less than, we're going to use a dashed line. So, just going to do something like that. Alright, we have our dashed line. So, we want y values that are less than this line. So we want small y values. So again, if I just kind of zoom in on my intercept there and think about this point, and that what we did for those last two examples is we used up above here, because those were larger y values, that would be going off to positive infinity. But now we want small, since we want less than that line. So I want to use the values that are on this lower side. So that's the side I'm going to shade in. In fact, I'll get rid of my arrow there. I'm going to shade in this side of the graph. Let me try to get as close as I can to that line. Ooh, yeah, it's getting abstract. All right. It's a big highlighter pen I have for this. And what you can do is just with a pencil, just kind of lightly shade side, or you can use pens if you want to. Just find a way of showing which side you want to shade in. And then it's done. And again, you can always check your answer. You would just basically choose any coordinate that's in that part of the graph right there, and it should work. Alright, last one here. Let's solve for y. So I'm going to subtract 3x from both sides. So I have -4y is more than or equal to -3x. We're going to divide both sides by -4, and we're dividing by a -4, so I want to pay attention to my symbol in the next step, because I'm going to have y. I'm going to change the symbol. It's going to flip, so now it's less than or equal to, and then we'll have 3/4 x. Alright, so this one, the intercept is 0, 0, since we don't have a value adding or subtracting on. Our slope is 3/4, so I'm thinking that is up 3, right 4. So I can start plotting points. So we have x and y, and a scale of 1. And we'll have a point at the origin here, and then I'm going to go up 3, right 4, up 3, right 4. Down 3, left 4 to go backwards a bit, get some more points. So with our symbol here, it's going to equal that line as well. So because we have equality there, we're going to draw a solid line. And now we just need to figure out which side to shade in. So we want less than. You might start getting an instinct that this is going to be our less than side. It's the side that's lower, and this is higher. But if it helps to think of that kind of zoomed in image, absolutely feel free to do that. Just for our last one, we'll go ahead and just shade in. Okay, as best we can. All right, so that's how we graph linear inequalities. Treat it like a linear equation, find the line, figure out if you're using a dashed or solid line, and then following the inequality, you're going to shade one side of the graph. And then you can always check your answer by choosing a point in that shaded region and making sure that it works.